Good morning. I'm Samina Ali Khan, and welcome to the AI Summit as part of London Tech Week, where Fujitsu is continuing to play a key role in demonstrating cognitive technologies in action. And to further that endeavor, Fujitsu has just made a significant business investment. So let's find out more about that from Keith Deere, who is the head of Centre for Cognitive and Advanced Technologies. Good morning to you, Keith,
morning,
and welcome.
Samina. Thank you.
You said last year about the UK wanting to become a superpower, really, when it came to science. And you mentioned it again in your speech today. What can you tell us about the progress that's been made there?
So, there's huge progress. So last year, the UK government published the Integrated Review, which I was a part of during my time in Number 10, which made that set the science superpower agenda. When you write these things, you're never quite sure what effect they're going to have, but actually, it's been fascinating watching it cascade through government.
Now, we said there's been an exciting development in that you have been made the head of Centre for Cognitive and Advanced Technologies. Fujitsu announced that yesterday here at London Tech Week. Tell us more about it. What does it involve and what are you hoping to achieve?
So the Centre for Cognitive and Advanced Technologies has been announced with £22 million of initial investment. It's aiming to create 200 high-tech jobs across the country. We'll be looking at some of the schemes, for example, DCMS's scheme that funds PhDs and master's programs in AI. Last year, I believe they're looking expanding that to a whole load of new technologies, of which we hope quantum might be one. We have, if people come to our stand here at Tech Week, we have Ellen Devereux, who's one of our quantum experts that we're currently putting through a quantum PhD, and she's a kind of microcosm of the investment we're talking about. We want to do that for eventually 200 people in high-skilled jobs. We're looking at creating co-creation campus, so that's where organisations, might be government departments, but equally might be our private sector businesses we work with, to bring their users' problems and data together with our experts, so you can kind of co-create solutions to previously intractable problems, but also look at new and emergent opportunities and how you seize those with new technology. And we think that co-location is really important. Some of it will still be virtual in the modern world, but an awful lot we think needs to be on a central campus, which we'll be looking to build out. So there's that, and there's much more. Vivek Mahajan, who's our CTO, has just come off stage talking about the CCAT, or the Centre for Cognitive and Advanced Technologies, as an innovation bridge with Japan. And what he means by that is a couple of things. The UK's Enhanced Partnership Agreement, which is the trade treaty that we signed post-EU with Japan, has only two things in it that's different to the trade treaty we had before.
Right.
One of those things is it talks about how the UK should be able to share national strategic data with Japan and vice versa, and that's going to need somebody to be a data steward to enable that data to flow. So who better than an Anglo-Japanese company ex-listed in the UK, for classified programs. Also talks about enabling small and medium enterprises from both countries to reciprocally access each other's markets, and we hope through corporate venture capital and enabling UK businesses to access Japanese customers and vice versa, we can play a big role in that. And then finally, there's kind of mission-driven innovation, so really big shared societal challenges, things that the market finds hard to address. So the Bayes Innovation Strategy has loads of those. We're supposed to look at anti-aging strategies, we're supposed to look at strategies to counter climate change, social cohesion, and Japan has a whole list that it's pursuing. And we think some of those might be brought together usefully to be pursued as Anglo-Japanese missions. I'm getting well out ahead of where we are, but they're the kind of things I want the CCAT to be doing.
Yeah, so these are big changes, aren't they? Then big impact on everybody, their life as a whole.
Yeah, I think so. I mean, look, the UK is third in the world for research in almost every kind of league table or chart you look at. We do incredibly well, and we're doing better. 4 of the top 20 universities in the world, or it might even be more than that, but are UK universities from 1% of the population. Like, we're really good at research. We're not so good at commercialising it. On most metrics, we've been going backwards. Now, you'd hope the announcements that I was talking about earlier that have been made this week around how we're doing in investment will change that. But if we succeed at the CCAT, we think we could be a new model of innovation for many companies. So we're looking at as much at business model and process innovation, how we bring people together to develop new solutions in different ways, as we are about technology innovation. The former has to precede the latter. You have to work together. So we think we could have a profound catalysing effect on the UK economy if we get this right, in helping to turn the UK around on that metric of the commercialisation of new technologies.
Okay, well, talking of business and technology, we know both change hugely, very quickly, and are impacted massively by advancements that we're seeing almost really on a regular basis. So where do you see us being in 2023?
I think this, as you say, the speed of technological change is such that those kind of forecasts are extremely difficult. I'm going to talk a little bit about this tomorrow, but in 2010 there was no machine learning anywhere outside of the lab, right? And within 5 years it was everywhere, in your Google searches, it was in Twitter, it was up in your Facebook posts. There's so much changed, and there were problems in 2010 that we thought would be completely intractable that are now totally solved and widely commercialised. So by 2023, I expect some of the things that we currently think will be impossible will have been cracked, and I'm with some of the quantum startups like Q&Co and Pascal in thinking that quantum computing will be here much quicker than some analysts predict, in my opinion. I mean, of course, I could be wrong, but I think just the sheer volume of global investment means that that's a thing that I think by 2023 it's not absurd anymore to talk about major breakthroughs in quantum computing, which would be utterly revolutionary for everything from science to commerce to politics.
So give us a specific example. I know I'm pushing you on this, Keith, but it is fascinating, isn't it? Because the impact is far and wide-ranging, isn't it? It's huge.
Well, let me take one of the examples I'll use tomorrow. So in 2010, we thought autonomous cars were something that existed perhaps in the Jetsons and sci-fi, and that was about it. And now they're widely deployed. There are autonomous vehicles in China that you can get in as a taxi. They've been testing them down in Oxford. I think by 2023, that will be an example of something that will be widespread. I think you'll begin to see vertical lift deployed much more. But what I mean by that is flying taxis, basically. Okay. I'm sure people will kill me.
We like vertical lift. It sounds good.
Flying taxis, I think, are not out the question by 2023. They're supposed to be being fielded in Milan. We have a hub in Birmingham. And then you have the widespread fielding of supercomputing, which I think is a thing that Fujitsu does very well in Japan, and I think we'll be doing that globally, which will speed up many, many operations for many companies and organisations. So there'll be so much that changes, it's hard to limit yourself to just one or two things, but maybe that makes it more tangible.
It does, and it's exciting. That's what it sounds like. Now, you referenced the National Digital Twin Programme in your speech today. What can you tell us about that specifically? What is it, and so how does it impact?
So the National Digital Twin Programme in the UK looks to... on the one hand, it's profoundly exciting. So I've talked about it as being as revolutionary for how we interact with information as the introduction of the internet. And you start there, and then you're rapidly talking about things that are really, really boring. You're talking about information standards and how do we connect data more effectively, and then how do we enable people to access that data. But if I make it more real, what the National Digital Twin Programme starts by looking at things like critical national infrastructure and says, how do we build a digital twin of, say, a power plant, for example? And then once you've got a digital twin, which is a digital object where change something in the virtual version changes something in the real world, change something in the physical, it changes in the virtual. So now you can monitor and adapt and optimize. Well, the National Digital Twin Programme aims to connect everything, build multiple digital twins where you have cyber physical infrastructure, where that power plant is connected to the water grid, is connected to your home, is connected to the new boiler that you get installed in your home, which has a digital twin. And so now that can be managed remotely and optimised, and you can predict cascading causal consequences. I could go on and on and on, but it changes everything. I mean, in Japan, we have a thing called the social digital twin that Fujitsu works on. That creates digital twins of people within that ecosystem that then begin to move around. So you can manage people's carbon footprints, you can make suggestions, it's really profound. And I do think it's part of the kind of introduction of the spatial internet, where people are interacting with augmented and virtual reality through connected digital twins in ways that will change everything from how you operate machines using digital interfaces rather than kind of keyboards, to how we might do tele-maintenance, where let's say I don't know very much about how to fix something in my home, but an engineer can come out virtually. I see them in augmented reality and they talk me through what needs to be done. So again, you start with something profoundly exciting. Then you have to talk about data standards and architectures and connections, and then you're back to, well, actually in practice, this is really, really exciting.
Yeah, my mind is reeling, to be honest, from the possibilities that you're talking about, and those were just on a simple level. It is like simulation, really, but real, isn't it?
Yeah, it's. So I should, if those that run the National Digital Twin Programme in BEIS were here, they'd be having a heart attack at the moment. So I should say, BEIS are focused on developing the information management framework and the thing that connects data in a way that makes everything that I'm talking about possible. Fujitsu is investing in something called the social digital twin, which looks at some of those other technologies we looked at. And then that augmented reality and virtual reality layer is something that many companies, including us, are really pushing, because we think it could be so profound for commerce. Can I give a couple of examples of where it's real now?
Yes, please do, yeah.
So, for example, in Formula One, many Formula One racing organisations, they will be racing a car on the track, say in Bahrain, for example, and they'll have a digital twin of the car as it races that they might look at in their headquarters in the UK or Italy or wherever. And they're constantly looking at the systems maintenance and both optimising it through AI, but also intervening to say, actually, we've just changed our race strategy, so we need to adjust the car's engine in this way to make it perform. Similarly, with McLaren, so McLaren sell high-end cars as well. And if you're, I don't know, but maybe your McLaren, a car that you have in the garage, right? If it goes wrong, you can drive it to the local garage to have it fixed. But there's only a small number of engineers that understand. So your local garage can now have the virtual reality engineer that comes up, or augmented reality that comes up, and they see them through their augmented reality glasses. And she might then talk the local mechanic through what needs to be done to fix your car, as an example.
Right.
So that's the kind of thing you can do through the kind of technologies we're talking about.
So it's complete mirroring in effect. How far away is that, or what sort of timeline are we looking at?
So there are challenges to instantiating many individuals in those kind of virtual environments, and there are lots of people working on solving those problems. The connected digital twins and cyber physical infrastructure, that's here now. We can and do deliver that for clients and customers. So there are elements of it that are here now. There are elements of the things I talked about, like digital twins of boilers, the Internet of Things, the power grid. All of that can be done today. Right. The augmented and virtual reality solutions can be done, but have some limitations on the fidelity of the simulation. And, for example, it might not update as fast as you want as you're trying to point at something. There are all kinds of challenges. And there are so many different technological layers that have to come together to enable this. There are still some challenges that need to be solved to deliver the full vision, but in my view, by 2025, that will all be here. Fujitsu will be at an expo in Osaka talking about how we've done this, working with BASE and working with other partners. That's the vision, and something I want the CCAT to play a key role in enabling.
Yes, so that's not that far off, is it, 2025? I'm just thinking we should talk about emerging technology, because it can be viewed as a nebulous concept by some people. So how do you make something like artificial intelligence saleable? How do you sell that to somebody and put it to them in such a way that they accept it and want it?
So I think there are two things. I say to our deep tech researchers that if I'm talking about the technology to a customer, I've probably already lost the sale. So I think you need to be talking about how it solves problems.
Yeah.
So, for example, we work on a solution that I probably shouldn't go into too many details about at this stage, but a cutting-edge explainable AI technique. And the brief to the researchers and engineers is that when this program finishes in 11 months, I want the first slide to show the amount of money that it could save or generate for the customer or consumer. That's the first thing. That's slide one. It saves you X. It identifies Y amount of assets that might be available, or it looks at fraud. So in this case, that you might freeze or respond to stop your company from losing money. So that's one example where you sell the solution, not the technology. The other element of your question is the safety element,
yes.
Right? And I think like that big investment in explainable AI. Fujitsu in Japan is investing in explainable AI solutions, and we're doing it really heavily here in the UK. And that's another thing I want the CCAT to do, to start thinking about AI safety and the things we need to invest in. Building the seatbelt before the car is the way I'm going to describe it tomorrow. So,
right.
One, you sell, this is the solution. Two, here are all the risks, and here's how we've already thought about how we solve those risks. I think there's a real danger in pursuing these solutions with untrammeled enthusiasm and then worrying about how we fix it later. We've done that with previous technologies and it's not ended well. So
it's much more transparent, isn't it?
That's the aim.
What you were saying.
That's the aim, is to say that these are the risks and we're already working on them. Or ideally, we've already solved them long before you deploy anything. I have a colleague who works on AI and data ethics, for example, who's looking at how you make models more robust so people can't cause them to collapse by interfering, and how you check data before you start building a model to see if it has any kind of bias, whether that might be gender, ethnic, national, whatever, to make sure the data itself is representative before you ever feed your model. So hopefully the models themselves are as fair as they possibly can be.
Right. Exciting times then.
Yeah.
Final question to you, Keith. What really gets you excited? And what are you most looking forward to in the next 12 months? I
think the two levels, the conversation with government about those really profound potential Anglo-Japanese collaborations. I joined Fujitsu to tackle that science superpower mission of how do we commercialise innovation faster, and I've been given the opportunity to make that happen.
Yeah.
So at the top level, there's that element, and helping to deepen Anglo-Japanese relations, which my background's in national security, and I think that's crucial for our future prosperity and security. But then day to day, you have to get out of bed and deal with all of the normal challenges. And I think what's exciting there is we're being given the freedom to innovate, not just in technologies, but in how we run the company. The CCAT's being given permission to try business model innovation. You know, how do we shape? How do we sell? How do we go about our daily work? And how do we design processes that maximise innovation? And that's really exciting. It makes us like a catalyst or a petri dish for how the UK does innovation more effectively. So different levels, so the day-to-day and then the profound, and they're both equally exciting in different ways.
Yeah, well, we wish you all the best, Keith. Thank you very much for sharing your knowledge today. It's been fascinating talking to you. Thank you very much.
Thanks, Samima.
And if you do have any questions for Keith, then do get in touch, and we'll get you in touch with Keith, and hopefully he'll be able to give you some answers as well. Additionally, if you want to discover more about Fujitsu's cognitive technologies in action, which is what we're all about today, and the business value that can unlock, then please visit the link. It'll be displayed on the screen now. And thank you for watching.